So we have a quiz in summer next Sunday in the workshop two. Until the fall sun. Right, so last time we finished talking about the different distributions. Maybe we talked about the and before that we talked about the Gaussian, the binomial, and the Boltzmann. So basically we have several variables that we discussed so far. And this should give us basically the opportunity to be able to solve different kinds of problems depending on the situation. Whether it's a counting problem, it will be Boltzmann, whether it's a repetition of an experiment where basically class fail, and so on, two outcomes with certain for one outcome, in this case binomial. If it is a signal in Y communication should be if the phase is random, then it will be on. If the power should be exponential, if the voltage should be raised. So basically this should have covered basically many different applications. Today's lecture will be devoted for what we call the conditional density and distribution. So far we discussed random variable, and before we said, okay, in order to describe a random variable, we find what we call a probability density function, which provides you how is this total probability twice divided or distributed among the different values like x, right? And then we talked also about the CDF, which is the cumulative distribution. How does this probability one keeps accumulating as x increases from the name cumulative? Now, so far we haven't talked about if we condition, what would be this distribution of the random variable if we have certain conditions, if something happens. Okay? And this is what we'll be doing today. So if you look at, just a quick review about the conditioning, if you have two events, A and B, until now, so far we are not talking about any random variable, two events, then the conditional probability of an event A given an event B had occurred, it will be given by this, which is probability of A given B, which is the probability of A intersect B divided by probability of B. And we said that intuitively, what happens is when you condition in B, the new sample space will be B. Okay? And because of that, we are divided by probability of B, because this is a new sample space. So it will be basically the probability of A given B, it will be whatever common factor between A and B, whatever possible given B, what will be possible, the common factor between B and A, divided by probability of B, because the new sample space is now. And basically we illustrated this using the Venn diagram, and we discussed several examples. Now today what we'll do is we'll extend this for random values, to include random values. We do this by following the same definition, starting by the conditional CDF. Conditional CDF. Conditional CDF. So basically now, if we have a random variable x, then we can define the event A, which is A equals x less than specific value x. Okay? And then we can define the conditional distribution function as follows. Fx x given b to be equal to the probability that x is less than a number x given b. So this is the condition. So think about this as an A. So it will be fx of x given b equals the probability of A given b. What is A? Is the probability that x is less than a specific number. So following the same definition here, it will be the probability, this conditional probability or conditional CDF will be the probability that x is less than specific number given b, which is equal to the probability, the intersection between these two events, x less than specific number and b, these two events, divided by probability. If you take some example, however, this is basically the concept, the main concept. Any question? Any question? طبعا the conditional CDF is CDF. What is the security that we talk about CDF? It starts at minus infinity, it's 0, because this is the probability that x, the probability that x is this than minus infinity, which is impossible. So given B will be the intersection between x less than infinity and whatever B is. Again, it will be 5. So this is 0 because of that. And this is the probability that x is this line or equal infinity, which is the certain. Around the value of character and about rather than infinity. Given B, then basically the intersection will be what is the intersection between, so this is basically what is the probability of x given less than infinity and B intersection x is less than infinity and B. Less than infinity is the certain event. So as if you are saying the probability that of S, which is the sample space, intersect with B. What is the probability of S intersect with B? It's equal to the probability of B. Divide by probability of B, this gives you. On the other hand here, probability X less than infinity intersect with B is as if you are saying probability of 5 intersect with B, which is. So these are the first two properties, and they are the same as without condition. So basically, we see that all the properties follow the same properties of a CDF without condition. Similarly, this is a probability function. It's the probability of x less than specific number given B. So it has to be less than 1 and larger than 0, right? And if I'm comparing x2 with x1, then the probability, the PDF at x2 is larger than or equal to x1. So this is again a non-decreasing function, similar to without condition. And if I want to calculate the probability that x lies between two numbers given B, it will be the CDF of x2 given B minus the CDF of x1 given B. As I mentioned, when we condition, what happens is you have a new sample space. So all the different properties follow. No change. And it's continuous from the right. Further. Yeah.
I want let x is bigger than or equal to x1 and less than x2.
Yeah, here equal and less than. Well, in this case, you need to go, if it is not discrete, it doesn't matter. If it is continuous. When it is discrete, you have to go and see where basically you are adding here. And if you are adding here equal to, then you need to basically take care of this delta that will be added. Okay? Because if you add equal to and you have a discrete, then basically the additional delta will be there, right? You need to take care of it. Okay? So now we go over the definition of the density and then we'll have examples. The density function, whatever you find as the CDF given B, it will be the density. If you differentiate with respect to x, you get basically the density given B, which will give you how is this sort of one among the different values of x given B has had. So again, if you have discontinuities, then basically fx of x will have step functions, and fx of given B will be impulse functions. Similar, same. Now, if you go to the properties of the density, again, this is a derivative of a non-decreasing function. So it has to be positive because the function that you are differentiating either increases or stays the same, non-decreasing. And again, if you integrate over minus infinity to infinity, you get 1. The area under the curve is always 1. In this function. And if you want to find the CDF, simply integrate the PDF from minus infinity to x. And if you want to calculate the probability that x lies between two numbers given B, you need to integrate between x1 and x2 of this conditional PDF. Let's have an example, because it seems that these are rules only over. Let's have an example. We have this table that shows the distribution of, we have two boxes, small box and the larger box. Okay, the probability that you select, as if you are picking a box, and then you are picking whatever inside the box, certain balls, red, green, and blue. Okay, so the probability that you select box number 1, the small one, is 2 over 10. The probability that you select box number 2 is 8 over 10. So basically, selecting the one of the two boxes, you have a small one and a big one. The probability that you pick box number 1 is 1/5. The probability that you pick box number 2, which is 4 over 5 or 8 over 10. Now, in box 1, we have 5 red balls, 35 green balls, and 60 blue. While in box 2, we have 80, 60, and 10, respectively. And the total is this. Now we can ask you the same questions that we did in homework number 1 and quiz number 1. For example, let's go over this. What is the probability that x, and we define, by the way, the random variable x here, to be equal to 1 if it is red, so x here equals 1 if red, 2 or if green, and 3 is if blue. So this is the definition. You can define your own value. This is our value. Okay? Now we can ask different questions. For example, first of all, what is the distribution of x? Can you find the distribution of x? This is discrete or continuous? Discrete or continuous value? Discrete. Why? Take only 3 values or discrete number of values. Okay, so it's not a continuous number. And because of that, the PDF looks like PDF impulses. Impulse at 1, another impulse at 2, another impulse at 3, right? Similarly, the CDF looks like what? Step functions, series of step functions. 1 at 1, another step added to it at 2, a third step added to it at 3. Huh? So we know the shape, we know the only remaining is to find the probability, because the probability of x equal 1 will give you the delta, the length of the delta at 1, the length of the delta at 2 is probability x equal to 1. So let's find out what is the probability. So basically, we have 1, we have 2, we have 3, and this is x. And before conditioning, let's talk about fx of x. What is the PDF of what is the probability? So basically, we say that these are deltas. What is the probability of x equal 1? 85 over 250. Anybody agrees? كلكم متفقين على الشيء. Again, you are following the same mistake. These are not equally likely. If they are equally likely, this. There is a high probability that you select P2, and there is a lower probability that you select P2. So you cannot just say probability x equal 1 is 85 divided by 2. So this is not equal. Because I trying to emphasize this common mistake. This is not equal to 85 over 250. This is wrong. Okay? H equal to what is wrong? What do we do? What do we call this? Okay? So basically we find probability x equal 1 multiplied by, sorry, given. Fine. 250. So probability of X given, yeah, B1, multiplied by probability of B1, right? Plus probability of X equal B2, sorry, equal 1, given B2, multiplied by probability of B2. Right? What is this equal? Probability of X given B1, what is it? 5 over 10. Over total, 100. So we look at probability given B1, it's basically the number of threads divided by total in B1. Multiplied by cam. What is the probability that X, that we select B1? 2 over 10. X. Plus, what is the probability that X equal 1 given B2? We look at this line. 80 over 150. Multiplied by 8 over 10. Okay, and so you find the number. So basically you have certain number, certain whatever. We'll find it in the next slide. So this is basically the probability of X equal 1. So this is this. You can find similarly probability of X equal to us. However, until now we didn't say anything about condition. Now, if I want to find what is the probability that X equal 1 given B1. هنتكلم قلنا ايش هي given B1 equal كم؟ 5 over 1. X equal 2 given B1, it's 35 over 100, right? Given B1, what is the probability that X equal 3? 60 over 100. Okay. Now, if I want to find the PDF of X given B1. Again, given B1, what happens? Again, عندك انت still discrete value, right? It takes 3 values given B1, right? So it's 3 deltas. So what are these deltas? A delta at 1, a delta at 2, a third delta at 3. The remaining is to find these probabilities. We found already the probability that X equal 1 given B1. نحن قلنا كم equal to? So this is the probability of X given B1, X equal 1 given B1. This is the probability of X2 given B1, sorry. And the third one is the probability of X3, X equal 3 given B1. And you get this figure. Come on? 3 deltas with different amplitudes. If you want to find the CDF, you integrate. So you get basically the same numbers, but step functions. 1 and 2 and 3. Okay? Now, تكلمنا على how to find the probability. Now let's sketch. The sketch اللي قبل شوي تكلمنا عنه اللي PDF of X. The PDF of X was this. Let's see. X probability X equal شرحناها فوق. It's 0.435. This is it. الأزرق هذا. So the blue one here is the PDF without condition. So the PDF of X looks like the blue. بينما the PDF of X given B1 looks like the reddish one. اللي هي 5 over 10 and 30 over, sorry, 5 over كم قلنا? 100 and 35.35, 0.05, 0.35 and 0.6. The red one is the conditional PDF. What do you think about this? Why does the conditional PDF look like different, totally different than the original PDF?
You have some space.
Huh?
You have some space.
Different some space. الآن, given B1, you can see that the number of reds in B1, which gives you X equal 1, is very small. بينما if you look at the total, and given that the selecting B2 has a larger probability of 8 over 10, شوف كم تغيرت probability of X equal 1 من 0.05 إلى كم؟ 0.43. So the original PDF, without conditioning, without knowing that I selected B1, the probability that I get X equal 1 كم 0.43. Given B1, it became 0.05. because again given B1 تغير sample space تغير picture تغير the form. Similarly, if you look at 3 مثلا 3 the probability of X given B1 كانت 60 over 100. However, looking at the 2 boxes and knowing that the probability that I select box number 2 is larger, to come how many blues you have? 110 only out of 150. So when you calculate the probability of 3, X equals 3 only without any conditioning, it is much smaller. It's equal to 0.17 compared to كم هذه كانت؟ 0.6, right? So conditioning here, you can see that you have a different sample space because you have a different sample space. اليوم السكرين هذا هذا وين مكانه بس معليش هذا ايش يسوي هذا؟ لا شوف انا وين اضغط وهي وين تيجي كوني مسحت هذه النقطة مسحت البلو احتمال والله الخوف الشاشة هذه ما تكمل مع الضغط اللي عليها مسكين غالبا some Chinese يقول بس seems انها very expensive not something different. Oh, I didn't show the screen. طيب معلش let's proceed نشوف الآن. اوكي طيب خلينا نحاول نقلل الحركات. طيب شباب. So basically now you can see ال PDF وال CDF كيف شكلهم ال conditional and the original PDF. Now the CDF. By integrating the PDF gives you the CDF. Like look at now, for example, if you ask yourself without conditioning, what is the probability that X is less than 1? Strictly less than 1. X is less than 1? Given B1, can X be less than 1? So in both ways, it's 0. What about X less than or equal 1.5? 1.5 means X equal 1. If there is no conditioning, if I'm not conditioning at B1, let's say I select B1, then this will be 0.05. Sorry, it will be 0.437, which is because we have many red colors in the second box, and the second box has a large probability. But if I put the condition that I select B1, I get only 0.05 because I have only 5 out of 100 balls. And so on. So you can see that without conditioning, the CDF increases rapidly compared to the PDF. Sorry, the conditional PDF, conditional CDF. نفس اللي سويناه قبل كده في chapter 1. However, here the only difference is what we do. We only define a random variable. سميناه X. قبل كده ما كنا نسميه X equal كذا. كنا نقول what is the probability that بالكلام كنا نقول probability of selecting red given صح؟ هنا لا كنا نتكلم عن resistors بتتذكروا الكلام هنا لا احنا سمينا بس عشان to get rid of the details we defined the random variable and then we proceeded with the PDF and the CDF. تقريبا نفس اللي كنا نسويه في chapter 1 except that now we are talking about a PDF and a CDF. هذه الآن إلى الآن يسموها conditional probability or PDF and CDF. Now what about if I'm conditioning ما عندي الأوردر PDF box 1 box 2 لا أنا I have a PDF that looks like this or a CDF that looks like this واحدة منهم. And I'm interested in conditioning that X, the condition will be that X is less than مثلا 2. So my question will be, what will be the distribution of x given that x is less than 2? This is arrangement condition. Okay, واضح كده? So here it will look like this. We will define a new event B, which is the condition. This is the condition. The condition here is a range that x is below certain number, B, where B is any number, any real number. Then in this case, I can ask myself, what is the CDF of x given B? This is B, right? It will be x less than B, probability, so the CDF of x given x less than B, which is by definition, this is the probability that x, when I say fx of x, means the probability of x less than a number x, given x is less than or equal to B. Now, using the conditional probability, this is equal to the intersection between these two periods, x less than or equal x, x less than or equal B, divided by the probability that x less than or equal B, which will be equal to, depending on where B is located in this place. And the first case, is when B is less than x. The first case is when B, شوفوا هنا الآن عندنا the intersection between two events, x less than a specific number x and x less than a specific number B. الانترسكشن بينهم يعتمد على علاقة x و B. صحيح؟ تمام؟ عارفين small x and B. Small x and B. X is the only variable. X is هو the definition of the event. So the relative relationship between small x and b, these two numbers, will give you what this equals to. So خلينا نشوف أول شيء أول case. Case number 1 when x is larger than or equal to b. Basically, if you look at the real line, x is larger than or equal to b. So it means that x less than or equal number x intersect x less than or equal b. هذه أول واحدة والثانية هذه أول واحدة والثانية هذه. So what is the x less than b? So basically this is the result of the intersection. Now the CDF x given x less than or equal to b, it's the intersection زي ما تكلمنا. What is the intersection? هذا هو intersection. X less than b. Divide by x less than b, which is b. By conditioning, what do we get? Why? Because I'm trying to find the CDF of x given x less than b. What does this mean? I'm trying to find the probability that x. I'm trying to answer the following question. What is the probability that x is less than or equal this number x, given it's already less than or equal this number b. It's already less than or equal this. It's certain, right? Given, I already noticed, I already observed that x is less than b. So what is the probability that x is less than a larger number? Which one? It's certain. Given x is the whole new sample space. From minus infinity to b is the new sample space. And because of that, the probability that x is less than a number x becomes 1. This is in the case that b is less than x. In the case we have this. Now, I show our case. The second case happens the opposite. When b is larger than x. Now, when b is larger than x, this is x. The intersection is basically less than x مجموعة جزئية من less than b. واضحة؟ This is a subset of x less than b. And hence the intersection becomes x less than b. هذا هو intersection. And I'm interested in the CDF of x given x less than b, which is the intersection اللي تكلمنا عنه. والintersection طلع x less than or equal to x. And what is this by definition? It's f of x. So the CDF of x given x less than or equal to b equals the CDF of x divided by, and what is this? It's equal to the probability that x is less than or equal to the new sample space. So الفكرة كلها هنا الآن I'm trying to answer the following question. What is the probability that x is less than or equal this number? Okay, given it's less than this number. واضحة؟ طيب given it's less than this number, what is the new sample space? From B. Because of that, I need to divide by the probability that x is less than or equal to. Because this is the new sample space. صار مستحيل given x less than or equal to b صار مستحيل إنه x larger than b. So the whole event here, right to b, becomes impossible because it's already observed that x is less than or equal to b. And hence, we need to divide by x. So if I give you a random variable and ask you, what is the probability that x, defining the CDF of x, given x is less than a number, then you need to be able to figure out what is this. So now, combining these two, depending on what is the value of x, so the value of x compared to b. If x is less than b, we end up with this situation, and we have the answer as f x of x, which is the original function without conditioning, the CDF, the original CDF. So CDF, this is the original CDF of x without conditioning, divided by divided by the probability that x is less than or equal to b. And if x is larger than or equal to b, you end up with a certain event, which is here basically. Clear? Now the PDF looks like, so it's still the CDF. So now if you compare these two, if this is the CDF of x, now look at the CDF, the conditional CDF, given x is less than b. It's either equal 1 or it's divided by, ايش رايكم الدينومينيتور هنا larger or smaller than 1? Denominator يا شباب, is it larger or smaller than 1? Smaller, it's a probability. It's the probability that x is less than b, right? So the denominator is smaller, which means that the whole thing is 1. إذا تحت denominator smaller means the whole thing is 1. هذا كله ايش؟ أكبر ولا أصغر من fx. So واضحة يا شباب؟ If the denominator is smaller, then you end up with the conditional probability is always larger than or equal. Conditional probability is always larger than or equal fx. Okay? واضحة الفكرة؟ At between 0 and b, for x between 0 and b, it's larger, clearly larger. And at b, it becomes 1. Again, it's larger. Regardless of what the value of x, it's 1. واضحة؟ طبعا دائما احنا نقول conditioning, when you condition, هذا ممكن يطلع لك probability أصلا. Conditional probability مقارنة بالnon conditional probability. لا ليش؟ because you are dividing by a smaller sample space. زي ما كنا نتكلم عن rolling a die. كم sample space؟ how many elements كان؟ 6 صح؟ طيب if I tell you that the outcome was even number. كم اللي sample space صح؟ 3. So it's small. Always when you condition, the sample space either decreases or increases. So the conditional probability is always larger than or equal to the non-conditional probability. Always. وهذا خلينا نكتبها هنا. Probability of A given B in general is always larger than or equal probability of A. This is always. And because of that, because the CDF, the conditional CDF is a probability and the CDF is a probability, it applies here. Okay, sure. You can see here that between 0 and before B, the CDF, conditional CDF is larger than the CDF. This is the conditional CDF, this is the CDF. At B, once you exceed B, the conditional CDF becomes 1. Because if once X increases beyond B, the probability that X is less than X, given X is less than B, becomes certain, and hence it has a probability of equal to. Let's talk about the conditional density and then have an example. Conditional density, it's the derivative. So basically, we differentiate the condition, the CDF, the conditional CDF. Now, the CDF can actually have two ranges, two fields, right? X larger than B, can be conditional CDF equal to 1. If I differentiate 1, what do I get? So basically, because it's constant, it doesn't change, the CDF, the PDF becomes 0. بينما in the first range, it was the CDF of X divided by the CDF at B. Now differentiating the CDF gives me the PDF divided by fx of B, which is the integral from minus infinity to B of the PDF. It's the same. And the denominator didn't change. The numerator became the PDF. Again, if we compare now the conditional, the CDF, the PDF could be a Gaussian distribution. مثلا بالشكل هذا يعطيك Gaussian distribution. The conditional PDF will be in general larger because we are dividing by a number that is smaller than 1. شباب, the denominator is not a function. It's a number. The denominator هذا عبارة عن probability that X less than or equal B. It's a number. It's a number. Number less than or equal 1 and larger than or equal larger than 0. Can it be equal to 0? ليش؟ لأنه if it is equal to 0, the whole problem collapses. Doesn't make sense. Means that this is not a possible event. So how to condition on an impossible event. So because this is a number, the conditional PDF is always larger than the original PDF. Until you reach B, the conditional PDF becomes 0. Why is it 0? Because it's impossible. Cannot happen. Fine. Now, let's have an example. We have an exponential distribution here. Exponential distribution, نتذكر كيف شكله. طبعا هنا we are giving you that starts from 0. And because of that, تتذكر exponential distribution كان في minus x في داخل minus a. There is no a, and because of that starts at 0. And it doesn't have anything multiplied by it. It's only 1, so it looks like this. This is a typical exponential distribution. Now I ask you, what is, and this is the PDF, it looks like e to minus x for x positive and 0 otherwise. So it starts 0 and then it reaches 1 and then decreases exponentially. Now the PDF looks like this. I'm asking you, what is the probability that x is less than 1 given x is less than or equal to 2? Okay. Or I'm asking, as if I'm asking, what is the fx at 1 given x less than or equal to 2? This is what I'm asking, right? fx at 1. طيب, let's see. What is the PDF? What is this? This is the PDF of x, the PDF of x given x equal less than 2. It's the PDF divided by the probability that x is less than or equal to 2. Right? This is fx for the range x less than minus 2. Sorry, less than or equal to 2. For x larger than 2, it becomes 2. So now the only thing is to just write this. You need only to find, we have already f of x, we need to find this. What is this? Is the integral. This is equal to the integral from minus infinity to 2 of fx of x, right? What is this? Integral هل minus infinity في شيء؟ From 0 to 2 of e to minus x dx. And if you calculate this, it will be 1 minus e to minus 2. So the conditional PDF looks like e to minus x, which was fx of x, divided by this, which is fx of b, of 2, fx of 2, and this is for x between 0 and 2. And it's 0 before 0, because we know it's 0, and it's 0 beyond 2, above 2. How
can you say fx1 given x less than or equal to 2, but in the condition we have less than 1, not equal?
Again, this is continuous. Doesn't matter. Going to continuous doesn't matter. When you put equality on it. The continuous you have to be careful.
عندي probability مو مساوي واحد.
Which probability?
No, x less than 1 given x less than 2.
هذه. أنت جالس تقول what is the probability that x less than 1 given it's less than 2 هل تساوي واحد؟ given it's less than 2 ممكن تكون 1.5 صح؟ فما هو certain إنه x less than 1 بالعكس لما تقول أوكي لما أقول لك what is the probability that x less than 3 given it's less than 2 إذا less than 2 أكيد بينما العكس اوكي فهنا الان البي دي اف الاوريجينال بي دي اف الازرق this is the conditional PDF simply given x less than 2 ايش اللي صار؟ هذه كله اختفى فالبروبابيلتي اللي كانت هنا جت على الاحمر عشان كذا احمر صار because it's less than 2 I know that x is less than 2 طيب نمسح شوي طيب أي سؤال يا شباب؟ Tell me that thing, please. هذا هو. هذا هو. Okay. Yeah, I didn't find it here. It's probability that x قلنا كم less than 1 given x less than equal to. And I already found the PDF, so I just need to integrate it. This is the integral from 0 خلينا ناخذ حبة حبة from minus infinity to 1 صح؟ fx of x given x less than or equal to. فنستخدم الريزلت اللي جبناها which is equal to the integral from 0 to 1 of what? e to minus x divided by 1 minus e to minus 2 dx. كم البروبابيلتي هذه؟ Integrating e to minus x, what do you get? Minus e to minus x, right? From 0 to 1, which is will be كأنها minus e to minus x from 0 to 1, so it will be like 1 minus e to minus 1 minus 1, so it will be 1 minus e to minus 1 divided by 1 minus e to minus 2. Right. هذا هو الفاينل answer. Try to find it in once. Okay. أي سؤال ثاني؟ So now you need to be comfortable if I give you any random variable and any condition, you need to be able to find the solution. خلينا ناخذ one example before the time. Yes, we have time. One example about the another example about some uniform. خلينا ناخذ uniform. Random. خلينا نقول إنه uniform random variable هذا lies between 3 and 5. عايش شباب help me out. ايش اعطيني تفاصيل اكثر. كيف اليونيفورم random variable؟ كيف شكله؟
1 over 2.
ثابت constant between كم وكم؟
Yeah.
3 and 5. كم الامبليتيود هنا؟
1 over 5.
Yeah, 1 over 5 minus 3, which is the area under the curve is 1. Now, what is the probability that X, what is the PDF? طيب خلينا نسأل الآن السؤال. Give me the PDF of X given X less than or equal 4. Yes, ma'am. Given X less than or equal 4. Given X less than or equal 4. What is the PDF? كم كانت البي دي اف قبل كده؟ بس عشان كم كانت البي دي اف اصلا؟ اف اكس اوف اكس. It used to be half. Used to be half for تمام امشوا معايا. Yeah, x between 5 and 3, so it was half x between 3 and 5. And 0 otherwise. Yes. So now what is fx given x less than or equal to 2? Yeah.
Between 3 and 4 0.
Is it half? ايش نسوي؟ given now given x less than or equal to 4. Given خلاص انا عارف انه x less than or equal to 4. اسال نفسي what is the PDF of x? If x is 3, can x be larger than 4? So it's 0 for كم? For x larger than 4 and 0 في البداية اللي كانت less than 3. صح؟ What do we put here for x between كم؟ 3 and 4 ايش رايكم؟ So it's 1. Why? Because given x less than or equal to 4, the new sample space is between 3 and 4. So you need to divide by the probability that x is less than or equal to 4, which is half. So it's half divided by half, which is 1. Any question?
أنا حذفت النيو ساوند سبيس وخليت الامبليتيود نفس
اي لا خطأ. You need to always divide by the probability that x is less than 4. ما يطلع half.
لا انا بقول انه 1 بس انه غيرت الامبليتيود عشان اغير الساوند من 4
Exactly. So the new sound it has the area and the curvature. Exactly. دائما كل مسائل في كذا طريقة أو كذا طريقة للتفكير. It's up to you. لكن at the end you need to be able to figure it out. طيب. So it looks like this. بس خلينا كم. هذا ال PDF basically هذا هو موجود. X less than يطلع لك هذا الرقم which is basically this number. Okay. And the PDF looks like زي ما قلنا. Exponential until you reach 2 becomes 0. The last example. We have here target. The CDF that you basically just tell me you need to basically get the target. ممكن تجيب اللي في النص إذا أنت ممتاز، ممكن تجيب اللي برا إذا أنت أقل، ممكن تجيب مكان بعيد إذا أنت ما تمام؟ الآن the probability that the CDF basically if this is x خلينا ناخذها as if this is x then the probability that you get something less than a number is basically 1 minus e to x squared divided by 800. هذا يسموه Rayleigh distribution. تكلمنا عنه. الآن we would like to find what is the probability that you get the bull's eye هذه يجي سهمك هنا given that إنه جاء هنا هذا التارجت وهذه الاي البول اي. So the probability that you get the bull eye is you get here given that it's in the target given انها وصلت هنا ما طلعت برا. What is the probability that you get inside this ball, this small circle? It's fx of 10 divided by fx of 20, which is the probability that x is less than 10, هذا هو 10 meters, given that it's less than 50. And now just substituting, you get it 12%, 12.3%. So given that you hit the target, the probability that you get inside 10 meters is only very small. It's almost 10. طبعا جاي نمشي عليها بسرعة وبعدين we'll continue. شكرا جزيلا.